Hi everyone, and welcome to my technical implementation showreel of the video game Stellae. Powered by Unreal Engine 5 and Wwise 2023, Stellae is the result of a collaboration between three teams, Slop, MAAAV, and ARTFX. First and foremost, I want to thank everyone who worked on this project with me. If you'd like to watch a full playthrough of the game without commentary, I've uploaded a separate video for that. Additionally, if you're interested in playing the game or learning more, you can find the link to our itch.io page in the description. Stellae is a third-person puzzle adventure game that follows Ible, Stellae Transporter, and Ulee, a star. Together, they embark on a journey through Oblivion where they must protect each other from enemies known as the Forgotten. For this project, I took on 3 key roles: lead sound designer, integrator, and voice designer. In this video, I'll be covering each of these aspects with a focus on the technical details of my work. Let's start with project management. Effective communication was crucial, both within the sound design team and with the broader development team. To streamline this, we use 2 dedicated Discord servers, making it easy to connect with the right person, typically a programmer or a game designer. I was responsible for managing direct communication with the larger team and then relaying the various requirements to the other sound designers and composers. For source control, we used Git and relied on spreadsheets to prevent conflicts. Whenever someone needed to work on a blueprint or a level sub-level, we documented it in the spreadsheet to ensure multiple people weren't working on the same element simultaneously. I dedicated a specific sub-level to sound design, which greatly streamlined our workflow. As a lead, it was my responsibility to organize my team's work. To achieve this, I created a sound list containing all the necessary information and a logical naming convention. This was the first project where I was responsible for implementing the audio, so it was quite challenging at first to navigate everything in Unreal and Wwise and to manage the workflow. However, I am very satisfied with my progress and I learned a lot throughout the process. Initially, I was solely responsible for integration, but I worked as if there were other sound designers involved. To prepare for potential collaboration, I set up a logical work unit structure in Wwise. When another sound designer later joined me for Ambience integration, this foresight proved to be highly beneficial. I'm well versed in nodal programming thanks to my experience with Max MSP, so I'm adept at organizing workflows to be easily understood by others. In every blueprint I worked on, I added colored command boxes to help future-proof the project and make it easier for myself and others to quickly locate past work. I also took care to avoid creating any spaghetti cable setups, ensuring a clean, organized system. First and foremost, it's important to note that I implemented an azimuth RTPC on all specialized sounds to account for the direction of a sound relative to the camera's orientation. For instance, if a sound is coming from 180 degrees relative to the camera's central point of view, it will be significantly attenuated to enhance the audio experience's immersion. In hindsight, I should have applied the same process to filters as well, not just the volume. I also implemented a listener probe. This approach ensures that the spatialization of sound is based on the main camera and the distance calculation relative to the defined probe, which is the main character, Ible. This decision addresses the challenges posed by third-person games regarding listener placement, whether on the camera or the character. It allows for simulating real listening conditions, enhancing player immersion by providing the best of both worlds. I wasn't responsible for integrating the ambiences. The task was handled by Lucas Moulin, one of my fellow sound designers. As such, I'll keep this segment brief and to the point. The pad ambiences and reverb were managed using Wwise's room and portal systems. Small metallic objects are scattered throughout the map. To enhance the ambiences, we implemented a system where when Ible's detection sphere overlaps with one of these objects, a sound or metal sound sample is triggered. Another system initialized at the start of the game plays an infinite loop of sound gust sound effects. This randomly selects the listener via automation, making the sound appear at a random location with a random delay between 3 and 11 seconds around the player, where it remains until fading out. I choose to use 5 different physical materials, assigning them to the appropriate physical surfaces. Afterward, I tagged each material instance with its corresponding physical material. I also tagged each animation for both Ible and the Forgotten with the appropriate animatify, specifying each foot separately. For example, if the right foot steps on mud, the mud footsteps sound will play, and if the next step lands on sand, the sand footsteps sound is triggered. This approach results in a more immersive and coherent sound experience compared to using a single anim notify from the center of the body. I then transmitted this information from the animation blueprint to the Ible or forgotten blueprints. To identify the surface types, I used the line trace by profile attached to the character's foot bone and directed toward the ground to check for a special profile designated for water. If water is detected, a Wwise switch is set before playing the appropriate sound. If not, a line trace by channel is triggered to identify the type of physical material the foot contacts. Setting up the water detection was particularly challenging as the technique I usually rely on didn't work properly in this project, requiring me to devise a workaround. The management of clothing Foley is fairly straightforward and follows a similar process to the movement sounds. I worked directly with the Ible's animation, placing anim notifies at key moments. 3 different speeds, slow, medium, fast, were used, each with its own anim notify to match the character's movement pace. When Ible moves too far away from Ulee, he experiences a growing sense of unease, which intensifies the further he gets. To convey this, I set up a system that alternates between 2 heartbeat sounds. As the distance between Ible and Ulee increases, the heartbeat accelerates. Every 5 milliseconds, the game checks if Ible is injured. This check only occurs if Ible has attached to Ulee at least once before and exceeds the max distance from star variable. I didn't rely solely on this variable because I wanted the sound to trigger before the visual effects and movement slow down, providing the player with an early warning that they are nearing the threshold. If these conditions are met, an RTPC value is applied to modulate both the volume and pitch of the heartbeats. Following this, the system alternates between 2 heartbeat sounds using a flip-flop mechanism with a small delay between them. This delay adjusts dynamically based on the distance between the max distance from star and max distance from start to stop variables. As a result, the farther Ible moves from Ulee, the more frequent the heartbeats become, with the second heartbeat gradually closing in on the first. There are 2 different ways to deal damage in the game, through a projectile shot from Ulee and a blast triggered around Ulee. I decided to divide the projectile sounds into 3 parts: shoot, travel, and impact, while the blast sounds are divided into 2 parts: shoot and impact. All these sounds are routed to a special bus where I've placed a Wwise meter to measure the audio levels coming from the sounds, which is connected to an RTPC output. Then, in my ambience and music bus, I linked the same RTPC to an output bus volume. This way, depending on the audio level coming from the weapon, the ambiences and musics are lowered to create more space in the mix. There were other effects that I implemented that don't need an explanatory section, so I'll let you see them in a short montage. The voices for the Forgotten were recorded by La Fabrique des Monstres, commissioned by ARTFX. I then cut, edited, and mixed around 400 raw files. Upon begin play, each Forgotten character initializes its own voice system. The programmers had already created a switch in Unreal, so I reused it. The switch changes the Forgotten's mode, chase, passive, dead, but I also added a specific timing within the animations to trigger spontaneous sounds such as falling, taking damage, or pushing. When the Forgotten is either chasing or in a passive state, they play the appropriate bark sound every 0.5 to 2 seconds, plus the duration of the audio asset to prevent overlapping. Whenever a specific voice sound is triggered, it overrides this loop without delay. The loop is temporarily blocked until the sound finishes, after which the regular loop is reinitialized. For Ible and Ulee's voices, I first submitted the document to the game designers who returned it to me completed. Slope was then responsible for finding the actors. Before the recording session, I prepared an Excel spreadsheet with the voice lines and proper name conventions, which I then imported into Reaper to ensure a well-organized session. Afterward, I cut, edited, and mixed all the raw files. Using the Excel spreadsheet technique saved me a lot of time as I could export everything with the correct naming.
I don't understand. What are you trying to tell me? I don't understand. What are you trying to tell me?
I don't understand. What are you trying to tell me?
Ithraim dai talasam. Ithraim dai talasam. Ithraim dai talasam.
In collaboration with the programmer, we developed an efficient system for managing character voices and subtitles. This system uses data tables that contain the following information: ID, subtitle text, the voice event, delay, and who's speaking. In the Game Master blueprint, we trigger the event for either Ulee or Ible, depending on the data table specifications. Character voice lines are triggered in two ways: directly within cinematics events or via a blueprint box dialog, which are activated when Ible passes through them. Using end-of-event callbacks and markers, we orchestrate full conversations between two characters.
The pain. It's gone. How? What happened to me?
Ithraim dai talasam.
Huh? Who's speaking?
Mayam varen.
As the voice line reaches a marker predefined in the Reaper, the system updates the index to display the correct subtitle at the right moment. When the audio finishes playing, the system retrieves the information, applies the previously set delay, and increments the index again. To reduce the number of calls to Wwise and avoid unnatural voice overlap, I established a priority system in Unreal. The order is as follows: death, voice line, damage, interjection. This is managed by Boolean variables that are set to true when an audio asset is triggered, blocking lower priority sounds, and reset to false via a post-event callback. I use the exact same Wwise parameter process as the weapon on Ible and Ulee's voices to enhance clarity of comprehension. The Unreal audio sliders are linked to 4 Wwise RTPCs, which control the appropriate audio buses: master, effects, voice, and music. Since the game completely freezes when paused, I set up an event that triggers both a pause all and a state. The pause all affects everything except the ambiences, while the state does the opposite. In the widget blueprints, I implemented all the UI triggers sounds: open, over, select, and close. I served as a bridge between the game designers and the composers, effectively translate the needs and desires of each group within the integration possibilities. Solen Falk assisted me in implementing the music within Wwise. In Wwise, we use the interactive music system, which is initialized at the start of the game via a post-event. To change the music, we set a state when Ible collides with a blueprint box collider directly within the cinematic sequencer and, in some cases, within a blueprint. We can divide the game design and musical intention into two main parts: music tied to specific events, cinematics, special occurrences, and the exploration puzzle phases. The puzzle state was particularly interesting to implement because the composer designed the music using a probability system. Created 4 short assets with several possible sequences. I also added a probability for silence to allow the soundscape some breathing room. And that wraps up my technical implementation showreel for Stellae. Once again, a big thank you to everyone involved. If you're interested in playing the game or learning more, don't forget to check out the itch.io link in the description. If you have any questions or feedback, feel free to leave a comment below.